But you understand why track error is not significant, and therefore the total distance is also not significant here?
Yeah.
It doesn't really, we can assume any distance, find the track error, find the angle here, but where are you going to use it? Because I know that I'm flying a track that is parallel, which is 125 degrees true. Now, when do you think you will need track error? I think out of the questions.
Both the tracks, the planned track and the TMG are not the same one.
Plan track and the track plane are not the same here. Now what I'm saying is, when will you need a track error to solve this question? What if was asked in the question, will you need a track error? Now in this case, to find the track to fly overhead, you don't have to have a track error. Now how can I actually fly this track? Can I actually fly the track? Am I in direct control of the track? What I need is a track, but what I have is my heading. If I want to fly a track of 100 degrees, I need to fly a corresponding heading corrected for winds. So when I paste heading into this whole picture, now you will need the track error, because I'm not sure what heading I was flying here. Now let me put that question straight here. I assume initial heading. This is 125, right? Now let me assume, since I drifted off to the other side, I assume that there's a starboard wind. So let me put the heading as 130 degrees. Is the heading, true heading, right? Now let's place the aircraft here. 130 degrees is, I was flying on a planned heading of 130 degrees, true, right? What is the immediate value that I can find out from here? When you have the heading and I have the planned track, what drift is it?
It is the port drift.
Now see, that again, drift is not a real consideration here. You don't have to think about drift, but I'm just trying to put that through just as a kind of revision, just to bring these things into. It's always measured from heading to the planned track. 130, 125, therefore it's kind of 5 degrees. What drift is it?
Port drift.
Because since the track is to the port of heading, or you can think that if I don't do anything about it, I'm going to get drifted to the port, right?
Yeah.
5 degrees port, this is the planned drift.
Yeah.
Why? Because it is between heading and planned track.
Yeah.
That is why it is planned drift. Now unfortunately we saw that the wind is actually much stronger, again from starboard, but much stronger than anticipated, and therefore even though I corrected for a port drift, I still drifted towards port, because if I have anticipated 20 knots of wind, now it's 30 knots. Probably that is why I still experienced a more port drift, right? Now you can see here from this particular point all the way I'm drifting also. How am I flying? Now you can see I'm maintaining heading of 130 because that's all what I know. It's a planned heading. I have no idea that I have drifted unless I find myself relative to the 160 point. So my heading is still here. At any given intermediate point, assume that I'm a very good pilot and I'm like to the dot, or I'm an autopilot. I'm just like I'm still maintaining a heading of 130 degrees true, and we assume the wind has not changed throughout the journey. You see, practically all these things is not possible. Therefore, there are variables creeping into it when you actually fly with all these values. It's not going to be to the dot. Now your experience is the one that kind of you eyeball and kind of correct it and you reach where you want to, right? All right. Now tell me, what heading should I fly? So at sea, I realized that I am off by 2 nautical miles because I eyeballed. Now I want to fly overhead destination. What heading should I fly? Now when this question is actually asked, how will you approach this question? You have to find the heading to be flown from the point C to fly overhead R. The process is the same. Always think from a track point of view. You settle the track first, understand the track first, and then paste heading on top of that. Because whatever you do, ultimately you have to fly the track. But to fly that, you need the heading. So first settle the track, understand the track, which we already did because the question was asking that. We already got the track. You told me that. You have to first correct for drift, for not drifting any further. Stop drift and then now track towards. Those are 2 steps. Stop drift and then track towards R. So when you stop drift, what is the track change here? I have to know that. Only then I will be able to know the heading change. Right? I know my initial heading. Now if I have the track change is equal to heading change. Change in track is equal to change in heading.
Heading.
In the same direction. So as long as heading was not there in the picture, we were quite comfortable in the previous question. But now we have heading in the picture, therefore to find the heading change, I have to find track change. because I have the initial heading, I just need the change and I can find the final heading. Now that is when this angle becomes a requirement. Now this angle is now equal to this track error. Now we need the total distance, otherwise you cannot find it. Right? Now it will change depending upon how much you assume. You cannot assume, you can assume 200, but we cannot expect the answer to be same with the total distance being 500. It's going to change.
Yes.
Now it's going to change. But the track towards your final destination is still going to be the same.
Will be same.
But the heading change required is going to be different. But you have to find the heading change, otherwise you won't be able to find the final heading. Alright, so now when you assume initial heading, you have to also assume QR, the total departure, the total distance to be say 120 nautical miles. Right? Therefore, having understood that this is 40 nautical miles from R, what is this going to be? This is going to be 80 nautical miles. Do one thing, I'll take a pause. You can actually answer this particular question and then we will add on to it. Otherwise you will have all these things together. We have assumed this total distance to be 120, therefore this being 40, this is going to be 80 nautical miles. Now you see how the heading is going to change as you kind of change your assumption here. Heading is going to change, but the final track is still going to be the same, 120 degree. You're just trying to reach here, right? All right. Now what is the scenario here? You have to find track error, right? To find track error, you use 160 again, which is distance
off
by
distance gone.
Distance gone. That's right. Into 60.
Multiplied by 60.
Right. What is distance of?
2
nautical miles.
Divided by 80 nautical miles.
80 nautical miles into
Multiplied
60.
by 60. That is 1.5 degrees.
1.5 degrees. Therefore, track error is 1.5 degrees. Therefore, what's the track maker?
It's the required one is what?
125 degrees.
26.
Anti-clockwise by 1.5. So it's 124.5 degrees. If I don't do anything about it, I'll keep flying a track of 125.5 degrees, experiencing drift. So what is the drift that I experienced as against what I anticipated? To find the drift experience, so the actual drift, I have to find the angle between the heading, but now with the actual track or track made good, always measured from the heading. What is the angle? 130 and 124.5 is 5.5. Right? And again, you can see that I'm suffering from a more 0.5 degrees more of port drift.
Yeah.
Right? Yes, this is the actual drift.
Yeah.
This is how exactly it's going to happen in the air when you fly. You have an anticipated drift with you, and that is just a base value. And if you've done your calculations, if you look at the forecast properly, the wind is not going to drastically change. It will change, but not like completely opposite, because then there is no use of forecast, right? So it's going to be seemingly around. Therefore, even though I know that I'm not going to get the exact same drift, I still know it's going to be somewhere around that that drift. So I won't have much to worry about. I have a closer base. I just have to work on that from that, right? All right. Now, yes. So now you see, now it's again easier. 124.5, 125 degree. What's the track change required?
It is equal to the track error.
Why is it different? Oh, sorry.
Track made good is
Oh, there's something wrong. Yeah, that's right. 125, and this is 1.5. Sorry, this is 123. 5 degrees. My bad. Right. 123.5 degrees, and you have still the 0.5 degrees is your track. 1.5 is your track error, which is the track change required. Right. Now, what is this track change required is exactly in the way we found out earlier, because it doesn't really matter what you take here, as long as this is equal to closing angle. This is only going to depend on these two values. It doesn't really matter how long this leg is. That's not going to affect these angles. What this is going to affect is this particular angle here, right? Therefore, this track change is 3. So what's the total track change required? 1.5 plus 3, which is 4.5 degrees. When I change my track by changing the heading by 1.5, I stop drifting. Now when I change my track by changing the heading by another 3 degrees, I'll start flying a track of 128. Right? So what's the total track change required? That is 3 plus 1.5, that is 4.5 degrees, and therefore that is going to be my
change in heading.
Change in heading. What is my initial heading? Is 130 degrees.
130.
I'm changing this to the right, 4.5 degrees to the right. Remember, this is the track error. Track error is always measured from the planned track to the actual track, and therefore this is going to be 1.5 degrees left, and therefore I have to correct so much by to the right, and again for the right, 4.5 degrees right. From 130 degrees, 4.5 degrees right means clockwise. So what is the heading?
134.5.
Final heading required to track towards the destination is 130 plus 4.5, which is 134.5 degrees. True. So you can see, if I draw the aircraft, I'm not drawing it because it's going to make it very clumsy. So it's going to be 130 here. I reach here, I have to turn again by 4.5 degrees, 135 degrees, and I'm going to fly a track of 128 all the way, and I'm going to reach here. Right? The one thing which I have to understand here is, what if this was not 80, rather I have taken it as, say, some other point, maybe 100 over here. Now my track made good is going to be like this. And now I have to make a track change of initially so much to stop the drift, but the next track change is still the same. That is why it doesn't really matter what your heading or your initial leg is, the final track change of 3 degrees is not going to change. What if I start from here? My track is going to be all the way up to here. Now I just have to make a track change of so much to stop the drift. Right? But sorry, not so much, sorry. So much to stop the drift, but the next part of the angle is still the same.
Yeah.
So understood why finding the track error was not significant in the actual question. It doesn't really matter where you start from. But what changes is your heading. Required to fly the track now.
Is it closing angle?
Yeah, so the heading change that is required is going to change. Final track which you want to change is not going to change. But the heading is going to change all over the place, depending upon where you start from. So keep that in mind. Otherwise, as such, so much of this thing is not required. But I hope when you put heading into the picture, now the whole thing is changing a bit tricky, right? Yeah. That's it. All right. So yeah, so you can just note this as well. Just putting this heading into picture.